It's over to you.
Right, okay. Just going to check. Mike, are you happy that this thing's on? God, he gave me what for last time, so that scarred me. Okay, look, this, rather than being just a presentation, this is actually a workshop this evening, and I've geared it more towards the newcomer. So anybody who's already had quite a bit of experience in astrophotography, please, if you'll just bear with us, because we're trying to encourage people to get into the hobby. So first of all, I want to spend about 5 minutes on capture of imaging. And for that, we use either a planetary camera, like this little one here, which just fits in the eyepiece of the telescope, or you can have a DSLR. And I'll show you examples of both. So, and by the way, if it looks like I don't know what the hell I'm doing, you're probably right, because my memory isn't quite what it used to be. Now, I'll just show you a couple of examples. First of all, so this first one, this was taken with a Takahashi telescope, a camera not dissimilar to this one here. And you can, if you have a look at it, you can see it shimmering. So that's a live movie. The focal length of that telescope for this would be about 2,000 millimeters. So it would have been a telescope with a native focal length of, say, 1,000 millimeters, and then with a 2 times Barlow. And we're going to be having a look at stacking that image just now. Then we'll get a little bit closer, hopefully. So that's with the same setup. Now you can see the atmosphere is really shimmering now. That would be at a focal length of about 3 meters. So that would be my standard telescope of 1,000 millimeters with a 3 times Barlow. And that gives you the sort of image that I look at to capture. Now, with lunar images, most professionals will shoot between 6,000 and 9,000 frames. This particular one is about 3,000 frames. And I've found personally that the more frames that you capture, the better your final image is going to be. Now, here's another comparison. If it'll work. Now this image, also at 1,000 millimeter, this was taken with my Nikon. Now you can see it's quite a short image, but it shows you with a DSLR, you can also take a very good image. Normally, the DSLR cameras take a different type of codec file, so you have to convert it to an AV file if you're going to stack the images, which you'll see just now. Finally, okay, that would be at 3 meters. That's what I look at Saturn initially, and that's what the initial image looks like. So it's not much to look at, but you'll see if we have time and I can process it, that image will improve quite considerably. So considering it's heavens knows how many billion kilometers away, I was quite chuffed to get that. Okay. We just stop this.
How do you get the focus?
Okay, the focus for this, I'm going to show you that now actually. And please, if you have any questions, once we get into the capture, I'll do the capture. I'm also on a fairly tight time frame, so we'll hurry along. Okay, so the software that I'm going to use to demonstrate tonight is going to be IC Capture. Let's just have a look here. Okay, this is the camera that I've got here. Now, it could be also a DSLR. You can see that this is actually live now if I put my hand in front of that. So that's actually sitting in the eyepiece. Now, please, if you have any questions, so I'm going to be sort of moving along at a fair clip, so if you have any questions, please ask them as we go. First of all, we need to make this frame smaller, and we also need to choose the right codec. So, we're going to choose the right codec. What is a codec? A codec is software which captures and compresses and then regurgitates the data that you capture on your camera. And there are any number of codecs available. So imagine that this is in the telescope at the moment. The next thing we need here, which is quite important, which is something that you raised, Steve, was the histogram. Now, the histogram is really a picture of the intensity of the pixels that you're capturing on that image. The maximum intensity, as you can see with my cursor, is 255. After that, it's white out. Now, what we'll do is we'll take off auto exposure. Now, the idea is to keep those black lines, or that image of all those pixels, well to the left of that 255, if you want to get a reasonable image at the end of it. You'll see as I move the exposure, which is just the same as a normal camera, you'll see the gain, which is the same as your film speed, being altered at the same time. So we come back again. So the idea is to get it about there. Once you're ready to do that, the next thing you're going to have a look at is, I was asked a question about focusing. Now you will actually have a live image on here, so you'll focus your telescope. Also, the better the focus, the more data that you're going to see appearing on the histogram here. And that also gives you an indicator of how good your focus is. But the live focus is the best way to go, in answer to the question there, Stefan. Moving over here, you would then go to where you would save the file. Next thing you'd say, right, how many frames are you going to take? Click OK, and away you go. So I have dumbed it down a bit, but I don't want to get caught up in this. That's how we capture images that you saw earlier. Are there any questions before I go on to stacking? Sure. They vary. So what you're looking at, if you have a look where my cursor is now, up in the top right-hand corner, that's frames per second, and you'll see that down below here you've got an exposure of 1/20th. If I move that to 1/5 of a second, you'll see the gain changes. So what I normally do would probably be about 1/10 to 1/15th of a second each exposure. The number of frames per second is also quite important. The amount of data that you're capturing is enormous. This particular laptop is just a normal laptop, but it has got four CPUs, and it's got about 16 megs of RAM, and it really struggles with some of the bigger files that we were talking about earlier. So it's quite important to bear that in mind with the number of frames per second. If, for example, I took this at 80 frames a second, this machine would struggle to get all that data, and also I'm not sure that my hard disk would be big enough to, because you're talking about gigabytes of data then. So with that problem that we were discussing earlier, it may be something related to that, Steve. Any other questions? I'll get on to stacking. Okay. So look, I've kept it very simple because I didn't want to bore people who, not aware of this sort of stuff. So we'll just get out of this. Okay. Now, sorry, wrong one. We need, where is Registax? Gotcha. Okay. Registax is a software which was given freely to the world by a guy by the name of Cor Birrefoot, who was a Hollander in 2008. It's the most extraordinary program, and towards the end of it, when we get to the final image, it really is like black magic. And I think you'll enjoy what you see. So what I'd like to do is, if you were going to use, for example, this planetary camera, this takes AV videos, which is what we're going to process tonight. But you could also be using a video from an ADSL camera. But you'd have to convert that to an AV file if you're going to use Registax to do the stacking. But there's lots of other stacking software. But tonight I thought I'd stick to planetary and lunar images. There's a reason for that. I've found that the skies here in Tasmania are very challenging from a cloud point of view. And with the moon and with the planets, most of your exposure times are fairly quick and short. For example, if you want to take pictures of Jupiter, you'd be looking at about 2 minutes maximum. Saturn would probably be 4 minutes of exposures. But the moon may be 8 to 10 minutes maximum. And that you can normally find between the clouds in the evening. So that's why lunar and planetary imaging is really not a bad way to start if anybody wanted to get into the hobby. Okay. We're now going to select, okay, let's pick this one here. Okay, I think that's a Sea of Tranquility, somewhere around there. Okay. Now, down the bottom here, where the cursor is, you can see there are actually 5,042 frames. The first thing one does, you need a reference point. So you need to choose a frame that you consider to be the best from a focus and image point of view. So you move this little cursor along the bottom, and you can see you're actually creating a movie. So what you're doing is you're trying to find an image which looks reasonably sharp compared to the others. I'm happy with that one. So that's image number 1220. Now, we're going to set align points. And we'll click on here. Now, it's going to say, what is it going to say? Just to remind myself. Yep, okay. Set points. Now, it's picked the best points for alignment of all these images. So it's picked a point on all those images, and it's going to put one image on top of the other and orientate it so that you get the maximum amount of data. That's what we're trying to do, is to create as much data before we create the final image. Now, we don't want to be here all night, so I'm going to limit the number of points here. You can see as I decrease this, you'll see the points disappear. So we'll make it really low, 26 points. Now we're going to go to align. Now, that's now going to be aligned, and you can see the percentage down the bottom here. And this is the time when you go and make a cup of tea. So you can see it popping on. Now, if I'd chosen 100 points, it would probably be about 20 minutes. And you can literally hear these poor machines grinding away. There's an awful lot of data that they have to process. Registax and IC Capture software, they're free downloads. It costs you nothing. And they're regularly upgraded for free. So they're just extraordinary bits of software. How are we doing there? 42%. God. It'll tell us in a minute. It'll work out how many are going to fall into that parameter of 26 points. And then we're going to choose the best ones. And I'll choose the top best 20 frames, so we'll keep it nice and short. Normally I'd probably choose the best 200 or 300 frames. But then again, we'll need another cup of tea. So, yes, and some scones too. So, okay, we're nearly there, 78%. Any questions so far? Yes?
Why did you reduce the amount of points? I mean, apart from making it faster.
Just speed. Because otherwise we'll run out of time tonight. I'm aiming for an 8:30 finish, and it's 20 past 8. I know he's got a few minutes up his sleeve, but not a lot. Okay, now there we have all the images aligned. So, okay, it says, let's go to here, show frame list. It's got quite a few actually. Just trying to see how many here. I think could be, I'm not sure if it's probably more likely to be 76, I think, and that's frame 20. probably. Anyway, here we go.
What's it done, Richard? It's just discarded the other frames. It's just picked the frames that are easiest to align.
Yeah, that's correct. Well, it's aligned them all. It's aligned them all. We're going to limit the amount of frames now. We're going to discard frames in a minute. We haven't done that just yet.
You're just on frame 76.
Yeah, that's right, on frame 76. Sorry, thanks for clarifying that. Okay, so that's on 26 alignment points. Now, we're going to check off, look, I'm going to say best 15 frames. You can actually pick a percentage. Now, this lower box here on the left-hand side, that's where you limit the amount of frames which are going to be processed. We can't be here all night, so I've chosen 15. Now, that's going to choose 15 frames on those particular alignments points. So there may actually be 50 frames in total. So let's see what it does. Okay, so we'll go to click on limit. Now, what's interesting about this is, so it's limited. It's actually showing you the drift from beginning to end of all the exposures. So there was actually, although this by scope was put on an equatorial mountain, I did everything right, there still was a degree of drift there. Okay, so we'll go to stack. Now we're going to put one image on top of another. And, yep, nothing else I can make any quicker here. No, stack. Okay, it's done it. Okay, that's now our final stacked image. That was nice and quick. Right, now we're going to go to the black magic. This is called wavelets. Now, wavelets, it's a lot of people have tried to explain this to me and I still don't fully understand it. It's basically sharpening. It's a sharpening algorithm which works at different levels. And I'll show you what happens here. So that's a very ho-hum image. But because we've stacked it, there's a lot of data in there which we're now going to expose. So watch what happens when I take this first little slider over here on the left-hand side. Watch what happens to the image now. Look what's happening. Now that's at just one particular level. Now it's only processing one particular area at the moment, that between those 2 points there. So we'll get rid of that. We'll go to the next level and give that. Now if you do too much, I'll show you what happens. You create something called artifacts and it starts to look unnatural. So now you've gone too far. So there's no hard and fast rule about this. It's something you play with. So we'll tell you the next one as well. And a little bit here, and that's probably enough. Then we click do all, so it'll then apply the area that we've processed to the whole image. And that would then be the final image. Now, with that image, you then save it. And you would save it as preferably a TIFF file that you would take into a program like Photoshop, or into something like Focus Magic. And you could do some more processing and make it even better. Any questions? How are we doing? God, I've got 8 minutes left.
Those programs, is there any equivalent for that?
Yes, there is. There is. I don't know offhand, but there are. There are, definitely. Yeah. You've got to search for it, but they are available. Okay, so we're going to get out of this. Yes?
Do you need to do the wavelets in Registax, or would you do it in your image processing program?
Doesn't matter. Doesn't matter. Doesn't really matter. This is the sequence of way I do things. You know, all these professionals, everybody's got a different method, and they all work pretty well. My guru is an American, Bob Piltz, who's retired now, but some of his images of the moon with very modest equipment are absolutely exquisite. They rival the big telescopes around the world, you know, just fantastic. Hey, have I upset your device? No. Okay. All right. Okay, good. God, don't want you glaring at me. No. Okay, so we'll get out of that. Now, we're going to do one more. We're not going to have a chance to do all. So we'll do that pretty poor image of Saturn. Don't know why that's over there. Try that again. I've upset it. Who knows? Okay. Okay, I'm just choosing a Kodak which is... Now, by the way, you can see where my cursor is, Steve. You can see the different frame sizes here. So always initially just pick that small one, so it's a nice small area. And I have no idea why this thing's on the left-hand side. Status bar. By the way, with all these programs, the interface can get very complicated. If you go to toolbars, you can see I've only got a few toolbars opened up. I try and dumb it down because otherwise you get lost in this stuff. It can get really complicated. Anyway, we are... Okay. Actually, okay, I know what I've done wrong. We need to go to Registax. That'd help. Okay. More haste, less speed. All right, here we go. Saturn. Okay. Now you'll remember that video that I showed you a little earlier? Okay. Pretty poor. Now this was taken with my refractor, so it's a 5.1 inch refractor. For planetary imaging, nothing really beats aperture. So if you've got a reflector, you'll get much better images, but I was pretty happy with this. I could almost see the Cassini division there, but you need a little bit of imagination. But let's see what we can do with it. Now, with planets, especially something like Saturn, there are no features on the surface that it can really align on. So the software allows for that. There's a little box on the left-hand side here which says align by center of gravity. And it puts a little red dot there. Now it's going to work out how to set all the images. We've already chosen the image as a reference point. All this is pretty right. I think what we'll do down here, we're going to go for the 5%, not less, we'll go for 5% best frames. Okay. Click set alignment points. So those are the points it's picked up. We'll go to align. Oh God, it's another cup of tea. Yeah, no. Nothing I can do.
Any questions while we...
Do you have a choice of software you use to convert your MPEG or whatever it is to AVI?
Yes, you look, there's a big choice of free software available. I've got one particular one which I can't remember the name of, but there's at least half a dozen out there which are free of charge. That's a good one. That's a good one. I think that's the one I've got on here actually. No, dead right. Good question. Yep. Yeah, Freeview. It's got a good name too.
Be careful with Freeview because it does put in some what they call candies, and you've got to be careful.
Oh yeah,
because
it's
you make sure you
is up to date.
and untick anything that it wants to install when
When you're installing it,
because you end up with some things that you don't want.
the defaults.
No.
Right, there you go. Okay.
Make all right candy because I don't want that.
Okay. Come on. 85%.
Interesting thing on 7:30 or what they call it now tonight about the dark web.
Oh, that's murky stuff. Okay, that's the final stacked image. Still looks pretty poor. So we're going to limit it to the best 5% best frames. Click limit. Stack them. Sorry, this will be the final stacked image. Sorry. Oh, there we are. Okay, that's the final stacked image. Now you can see it's applied a Gaussian blur, what they call a Gaussian blur to it. So the image is a bit more attractive. I can sort of vaguely see a little bit of a band there. Cassini division, I still need imagination. So, by the way, I read in the latest Australian Sky and Telescope that the distance between the surface of the planet Saturn and the inside ring is only 2,000 kilometers. They've now measured it. I thought that was extraordinarily small. So you look at the size of the gap there, but apparently it's only 2,000 Ks. Anyway, okay, so now we're going to go to wavelets. What can we do with wavelets? Okay, here comes the black magic. So let's see if we can get a little bit more here. Oh, Cassini division, just. are not going to get much better than that. But also, what we would need to do is now you can see the division coming up now, is have a much better sampling. I've kept everything as short as possible because of time. So that's how we would do the planet Saturn. Sorry? Exposures, look, the IC capture, with something like that, you'd be probably taking, it varies with the different planets as well. With Jupiter, because of the speed of the rotation of Jupiter, you're very limited in time, so you're trying to take as many frames as possible. The problem is the faster you pick up the frame speed, you've got less time to get the photons in, so that changes the gain and changes the shutter speed. So there's those three components that you have to play with. For Saturn, this is probably taken at about 15th of a second, I would think. Exposures about a 15th of a second. But with the beauty of IC captures, you can actually play with it and you can see what you're doing because you've got a live image. And from that live image, you can see if it's getting better or worse. And getting back to focusing again on the live screen, that's the best place to focus and look at the histogram. Any other questions?
That camera's USB interface,
Yes. Yep. That's that USB interface. Yep. Okay. That's a color camera. I've moved over to color, and Steve's got a mono camera with a color filter wheel. Now, if you are going to take color images and you've got a mono camera, of course, you have to do all of this with each filter. So RGB, red, green, and blue, and then you put them all together in Photoshop. Okay. Now, how are we doing here? Not bad. We won't save results.
Only focus on that first 2 or 3 wavelets?
Yeah, because once you get to the other wavelets at a different level, they work better on the lunar surface. But for the planets, they make very little difference at all. In fact, you start to get artifacts. So I normally just work on the 2 or 3. With the lunar surface, I'd probably be using the first probably 5 or 6. Okay. Now, something else I just wanted to show you. Now, we all know that astronomers, especially amateur astronomers, are very inventive. So, at the various astro camps that I go to, I have a look at the equipment that these guys make. And it's really beautiful. Unbelievable what these guys come up with. Far better than anything you could buy. And then, of course, it takes it to another level. I mean, look at that. I mean, it's absolutely fantastic. God, obviously an engineer. And it all packed up into this one box. It's just extraordinary. Okay.
It's a big mirror, that one.
Yeah, and then I came across this guy. This takes observing to another level. Now, not only can this swivel in all directions, the seat could be heated. And if you look closely, there's a stubby holder. I just thought that was fantastic, so I had to record that for posterity.
That is
Anyway.
But he hasn't got a big lino on there, he's just got a single...
Yeah, look, I would have had the most powerful binoculars.
Does that work with pedals so you can go left to right?
Okay.
I mean, like
No, you had it. Look, I don't know how. Look, I think he had this wheel here that he turned, and that swiveled him or something. Yeah, and he could. It was fantastic, unbelievable. Anyway, so that sort of concludes the little workshop that I wanted to do. I'm sorry I rushed it, but I wanted to cram in as much as possible and give you a taste, anyway, of planetary imaging with that type of camera. Next time we can do the DSLR, maybe take a little more time. Any questions or all done?
We've got Richard here at the moment, far away.
So the cost of that, Rich?
Okay, you're looking at about, this one here, you're looking at about $550 new. I've bought a lot of my equipment, including my Takahashi telescope, second-hand. I can't afford these new prices, and I've never been let down yet. I found that the members of the astronomy fraternity are very honest. And I got my one telescope from America, and I checked up on the guy, and he was a member of a club and everything else, and I paid a lot of money for my Takahashi. a lot of my lenses I buy new, but I would have no compunction with buying a camera like that locally. It either works or it doesn't work, you know. Yeah, so new about 550, and you probably pick it up secondhand for about 150, 200 bucks. Okay.
Have you thought of cooling it down?
What, to increase the sensitivity of the chip?
Well, just a bit of liquid nitrogen from your local doctor.
Yeah, I did that with my box camera with dry ice, actually. It's the only thing we could do. So with my Astro camera, of course, it's got Peltier electronic cooling, and we go down to minus 55 degrees delta.
That's good.
And so you don't need the liquid nitrogen. Okay, done. Thank you very much.